Okay, we're almost about to start. Welcome everybody to GNX first live webinar. The webinar goes around what makes and breaks your connectivity, your underlay connectivity, and I will quickly hand it over to Rick, who will go through the presentation. Thank you very much for joining.
Very good morning, everybody. Thank you for joining this GNX webinar. Today, I want to talk to you about a topic that is near and dear to my heart, and I think we're going to have a good time explaining it. If you have any questions during the webinar, there should be a Q&A button in the Teams app, so please feel free to use that. Submit your questions. I'll do my best to answer them either during the presentation or shortly afterwards. The presentation should last about 20 to 25 minutes, and then there should be plenty enough time for some Q&A. Again, thank you for joining. And today I want to talk about, like I said, a topic that is dear to my heart, which means that if we talk about uptime, that does not necessarily mean you'll have a good time. And what I mean with that is what I'll explain in the next 20 minutes, what really matters for your network underlay. But first, let me take you back a little bit in history and take you back to how a modern day network infrastructure is built. We call it the Great Network Transformation, meaning that globalization is happening. Of course, we had a little delay in that maybe with the COVID years, but today growth is back. People and are hybrid. So there's a very distributed model of where users are located, but also where devices are located and where data is located. These statistics are from a Gartner research where they will anticipate on about a doubling the amount of devices connected to the internet or some form of network connectivity by 2028, which is only 3 years away. We expect about 4x the network traffic. That means that we're going to double pretty much every year, like we did for the past 25 years. Again, there was a slight growth delay in internet traffic, but we see that picking up definitely again. And of course, the main driver for that is video, and more importantly, real-time video, like we're doing now. I'm presenting to you as from a video conferencing system. If this would be a Teams meeting, there will be interaction between each other, meaning there's real-time traffic going back and forth between users, meaning that traffic in each direction is important. And of course, distance between people is going to be important, because I will explain that a little bit later. The end goal here is businesses need better connectivity everywhere. It's not just going to be your head office and a few of your factories, as you would have in the past, that you would connect with an MPLS network. If there's network engineers in the room, this may be a triggering topic, but in the years behind, MPLS was a simple network infrastructure. The technology behind it can be highly complex and hard to configure and maintain. But as a user, as a consumer of the MPLS technology, the world was simple. You would go to a single vendor, usually a big carrier, a big telco that would have a global footprint, and those networks would be run by the same provider, with maybe some infrastructure that will be purchased in separate parts of the world. But in the end, the piece of the network that you would procure from this vendor would be yours. It would be a private network infrastructure that was usually secure, and that was yours. So it was private, it was guaranteed with high SLAs, but it was expensive, and it still is today. The thing is, in the past, also the network infrastructure was a lot more simple. If you look at how networks were designed, there was usually a headquarters somewhere, maybe 2, maybe per region in the world, but there was only a few amount of headquarters. The servers were in the basement or somewhere on the floor that was converted into a data center room. And then there was branch offices, whether there were offices, factories, workers, sales offices, or retail shops. Anything could go, and anything was connected via the MPLS infrastructure with a primary and a secondary link for backup. If we look at how the connectivity system has evolved, like I already said, we are now in a much more hybrid setup, that people are not always in the office, but they're also working from home in a high percentage of the time. We've moved our servers from the basements to real data centers, or colos, as we can also call them. And of course, we have the cloud, where a lot of our applications and data is stored, whether that's a piece of the cloud that we own, or whether that's an application that is hosted in the cloud, like a Salesforce or like this Microsoft Teams. If we introduce all these network technologies, the landscape of connectivity is completely changing. It's highly complex to understand where your users are, where your data is stored, and how traffic is flowing between each of these destinations. Meaning that connectivity is not just a commodity, right? If we usually talk to some of the people in the SD-WAN space, maybe they're like, just get some internet connectivity and we'll be good to go. Sure, that your connection will be up, but will your connection actually be performant, and will it actually be differentiating for you? So different types of connectivity, different types of areas to really look at as a differentiator, rather than just getting it as a commodity service. This also means that there's a continuous need for change. If we look at, again, in the past, you would procure an MPLS infrastructure from a single big carrier. But if we move away from that, where private connectivity is no longer a necessity, there's a lot of different solutions out there that can solve your problem with regards to private connectivity, but over the internet. Now we can use the internet as a reliable source for network connectivity. It is a trend that is happening more and more. By this research already from 2 years ago, Gartner already said by next year, 2026, about half of enterprise locations will only make use of the internet for their external connectivity. That's a big change. If we look back a few years, like early 2020s, that was not the case. We were talking to a lot of customers that were still looking at internet as a sort of a backup scenario where they would run their MPL, where they would run their SD-WAN offerings off. But as I said, next year we expect about half of large enterprises to only use internet for their WAN services. And like I said, that changes the landscape, how these services need to be configured, need to be procured, and need to be looked at and designed. The big change here is that I go from one or a few of these major operators in the world to hundreds or thousands of operators, ISPs, that can offer me a service, can offer me an internet service, access to the internet. The problem is, or at least that introduces a number of problems. First of all, how do I know what they're offering is actually any good? And the second is, how do I actually buy it? How do I buy from my factory in Mexico? How do I buy it from that local vendor there who only speaks Spanish or the local language in any country? And I don't do that as a local IT administrator. So a lot of things to consider and a lot of things to think about. If we talk to customers and we talk about the next generation of their network underlay or the next generation of their WAN network infrastructure, there's a lot of talk about SD-WAN and SASE. So the overlay technologies, how do we actually connect the offices together? How do we connect them together securely and provide the right services to my users? But of course, like I said, the underlay under it, the internet connectivity underneath it, will support that. That's the foundation of the whole infrastructure. If that collapses, then there's nothing left. If we also look at, this is the IT spend on a typical large enterprise, how the revenue is separated between that services overlay, the SD-WAN and SASE offering, versus the network underlay, we see that about 2/3 of the IT spend for WAN is done on the underlay and not on the SD-WAN layer. We see that that enterprises are not considering underlay as important as it should be. Like I said, they may consider it as a commodity, which we think is wrong, because that's where 2/3 of your IT spend will go with regards to your WAN connectivity. And this is what I already said. SD-WAN vendors have a nice story. They offer amazing solutions and amazing appliances that can go on site and solve a lot of different things. They're zero-touch provisioning. They come online very easily, and the configuration for that is much more rapid than it was in the past. However, they will have some smart algorithms and optimizations that they can do on an internet connection, but they can never fix a bad underlay. As you can see here, if you just get a few internet connections on site from even 2 different ISPs, it's gonna be good, and you can work with it. But we definitely see that is wrong. The foundation under your house is the most important part, even though it's completely invisible to you as a user of the house. If you have 2 bad internet connections, you can throw as much algorithms at it as you want. It's not going to fix a bad connection in the end. Even with diversity, it's a bigger issue. We know that a lot of service providers within countries purchase services from each other to get a better coverage in the country. And sometimes, as a consumer of those services, it's not really visible who the ISP is or it is visible who the ISP is, but the underlying infrastructure or the cables who provided that is completely invisible to the end user. It's not possible to see that if you look at the IP addresses, for example, because they're delivered by the ISP that delivers the internet service on top of it. Where in many cases, we've seen that with customers procuring their own internet circuits, diversity was a huge issue because they thought they procured it from 2 different vendors, and they did, but these vendors procured services from each other, meaning that in the end, they ended up with using the same underlying infrastructure or the same cabling, causing a single outage to cause both connections to go down. So what's the challenge of using internet as your backbone? Like I said, MPLS was easy, right? It was a huge backbone. It was highly redundant. And now we're using the internet. Now, what are some of the contradictories for using internet as your backbone? Well, to start, the internet started out as by design being unpredictable and unguaranteed. It started out as, of course, as a research network where a lot of different universities came together to connect to each other. And that is how it continued. As much people should connect to this global network infrastructure, and how we connect, or should we connect, and what rules do we put in place completely varies on a network by network basis, or autonomous system, as we call them in the BGP world. So we have no way of knowing how a certain vendor that I procure an internet service from as a user or as a consumer, I have no way of knowing how that vendor actually connects to different other networks and different other ISPs. And like I said, it's unguaranteed and unpredictable by design, which means that performance can drastically vary based on how what we call internet peering is actually being configured. The internet is also shared by design. It's a shared medium. So in the past, you would have your MPLS infrastructure as a user. With using the internet and using an ISP, it means that you will use a shared infrastructure to connect to other ISPs, because you will not have a global network infrastructure that covers that there's not a single ISP that has global coverage, and you will always have to partner with multiple service providers that may connect to each other and say that they can guarantee some performance between each other. In the end, it's always, like I said, it's always a shared infrastructure. So if there's a new customer coming along that has that wants to connect between the same ISPs, they will use the same connection that could or could not impact your performance. We sometimes hear ISPs saying that, or carriers saying that they do this with deterministic peering, which is just as much as saying we will connect to that other ISP for you. In the end, it's hard to verify that as a user and as a consumer of the technology. And then there's an even bigger aspect here. I call this beyond bandwidth. I want to revolutionize the way that we see how internet should be purchased and how it should be evaluated against others by not using bandwidth, but using something else. And I'll explain why. Like I said in the beginning, uptime does not necessarily mean a good time. Just because the network is up, it doesn't mean your users will be happy using it. And in the end, users or enterprise customers need performance and not just availability. Of course, we always talk to our customers about SLAs, getting them as good as possible, but not better is always the question, right? What do you really need in terms of availability for your circuit? But in the end, an SLA is just a piece of paper. And of course, there's caveats to that, but in the end, it's an agreement that the link will not go down. In the end, it will go down. There will be maintenance, there will be outages that are completely out of your scope of control. And what do you get then? You get some compensation of the circuit, which is nice, but it's not what you want, right? You really want a circuit, or at least the connectivity to your office, to be up and working well. So I can have as much SLAs as I want. If there's a few cable cuts, I'm still going to be without connectivity. So in the end, how do I design the best solution for my users? Of course, covered by SLAs, but it's not the most important part. And then, like I said, speed is not the same as performance. The way that internet product is sold is by bandwidth, right? If I go to, especially as a consumer, I go online and I see advertisements on TV or billboards where now get 1000 MB or get 4G on your local fiber connection. That's amazing, but it doesn't tell me anything. It tells me how much data I can download at some point, but where that server is located, how I'm connecting to it, there's a lot of dependency if I'm actually able to achieve that speed, let alone if it's important for my office at all. So what really matters is a combination of it all. It really matters. Of course, bandwidth matters for sure, but it's not, I would say in some cases, it's not the most important part. The most important part in a lot of situations is latency. And of course, quality of the latency packets are things to consider with regards to the quality of a connection. But latency is, I think, the most important part when it comes to office connectivity and having the right user experience for users. So this is not an audience that I can ask a question from, but I'll give the answer right away. If you think about the question in your head, how many network sessions or TCP sessions are needed to generally load a modern website? Would that be between 2 to 6 or 20 to 40? So this is just, I type in a URL, I click enter, and the website loads for me. How many network sessions have gone back and forth? The answer is between 20 and 40, which is, I think, crazy to think about if you think about to just load quite a simple website. But websites are not simple anymore. There's a lot of things are going on. So just downloading the main HTML and style sheets and some illustrations, that's not the problem. The problem is everything around it. So there's a lot of fonts, for example, that are hosted not on the hosting server, but they're hosted somewhere else on the CDN. There's analytics that need to be loaded. There may be some ads on websites that need to be loaded. There may be some videos that need to come from YouTube or somewhere else. So combining all that effort for a full modern, let's say, enterprise website to load, I need between 20 and 40 TCP sessions. Now, why is that important to consider? If you look at the life cycle of a TCP session, you see that here you see a typical session where 2 data packets are loaded. So on the right, you see the server. On the left, you see the client. In this illustration, on the right, you see a little bit of a loading time somewhere halfway, where it downloads a certain file to the client or uploads a certain file to the client that they receive. I added here a typical latency, which is pretty good. So the client to server latency is 28 milliseconds. That's very slow. Well, that's very low, right? 28 milliseconds is nothing. Although if your qualification in the Formula 1 is 28 milliseconds behind somebody else wins, right? So there's differences there. But 28 milliseconds is considerably low for latency. However, to set up a TCP session, it already takes 3 packets going back and forth to actually ask a question and send back that I'm okay with it, and then actually acknowledge that the session is started. So I'm already almost 85 milliseconds in before the session actually started. Then I need to download the data file. I need to process it. Then in the data file, it mentions that I need to collect some other assets, and then I go back and forth and collect those. So only downloading a single data file, so only downloading 2 different data packets here, I'm already 230 milliseconds in. And this is a low latency for connecting between a client and a server. This is really well. If you go, for example, to the US, the distances are much longer, so it takes a lot more time to actually get these packets going back and forth. So if I would triple this latency, which is not unheard of, that I will have like about 90 milliseconds of latency to a given server. Of course, the loading time also triples, and this is a single session. Consider this 30 or 40 times, and of course there will be ones that are that will be done at the same time in parallel, but there will be 40 sessions that have to go back and forth and collect all this information. So loading a website takes seconds and seconds. And of course, if the latency then triples, it takes three times the amount of that. So latency impacts every request, meaning every millisecond impacts your performance. And that is the cost of a poor underlay choice here. Considering your ISP is also considering where your data is. For example, if I start deploying resources in a cloud, the difference between resources that are hosted on the US East Coast or the US West Coast can be about 70 milliseconds. Whether or not I host it on the US West Coast or whether I host it in like the UK, that's another 70 to 80 milliseconds that I add there. So picking the wrong region for your data or picking the wrong resource for depending on where the users are located that will consume that data is going to kill your performance, and user experience will go down. And like I said, algorithms can help a little bit with this, but they won't solve the actual problem here. So what do we need? We need a leap forward, right? We need the breakthrough of the model where the only thing that an ISP asks me is how much bandwidth do you need, right? That's pretty much the only question they ask. They ask maybe how many IP addresses do you want and how much bandwidth do you need? That's the only questions that you can ask your ISP. So rather than going from just doing that, right? Going through that bandwidth decision, we should consider ISPs based on their previous experiences. Today, the connectivity world, especially the enterprise connectivity world, is a very manual place. It's very opaque, and it's hard to compare. If you are in, let's say, the network engineering world, where you talk BGP with each other, there's standards, right? There's standard terminology that you use to exchange information with each other. And there's even protocols that have been configured to talk to each other and that are highly interoperable. If you are on the procurement side of these internet services and you need to do it globally, then again, there's a complete difference in some terminology, whether or not you're in the same country or not. So diversity is a big issue here. What is diversity, right? Do you consider diversity 2 different IP addresses? Do you consider diversity 2 different access technologies going into your building? Or do you really consider it a full path diversity where all the fibers are traced and everything is completely separated? And of course, typically, because the industry is quite opaque, vendors will overpromise. Will say to you that they are the incumbent in a certain country. They will say to you that they're the best of the best. But how do you know? Right? There is not really an easy way to compare all of these vendors with each other. So based from gut feeling, based on marketing feeling, right? If I look at the billboards, I see all the big names out there, but I'd never see the little ISP down the street that can actually deliver me an excellent service. We need to go from a gut feeling and nice pitches to actual measurable performance, basing your vendor on data rather than like I said, just a feeling. And of course, we need to automate this whole thing. I cannot, as a typical enterprise IT administrator, I'm not able to reach out to 1,000 different ISPs and ask them for a quote because it's a manual process. There's no way I can type in an address and get all of these quotes automatically from all of these different ISPs. Plus, I need to onboard them. I need a way to pay their bills. I need to talk to them. And then if I ended up with 15 different vendors in 10 different countries, I also need to actually know who to talk to. And when I have a problem, there's 15 different network support people that I need to, NOCs that I need to talk to. So it's a hard problem to solve. But of course, there is a solution. We started our company GNX with this promise in mind. So breaking through the opaque model of how ISPs are dealing with enterprise connectivity, making it simple, making it standard, and making it transparent to actually source connectivity from all over the world, from thousands of different ISPs, based on actual data and actual historic performance, which ones are actually good for you to use. Through a single platform that we call GNX Plus, you really type in your address, you get multiple results for your addresses because we don't want to lock you down into a single solution that we feel is the best one. We think that especially IT administrators will have plenty of knowledge to make that decision by themselves, but give you the right information and the right data that is standardized in a single way. So you only have one contact, there's one contract with us and one platform to actually source this from. How do we do it? We sell it. We offer it in multiple different categories. So I've talked about internet access a lot in this presentation. Of course, there's still room for some private connectivity that we call point-to-point cloud, point-to-point connectivity. And in the end, there is fabric solutions that will solve your problems by connecting into a cloud in the right way possible. Because I can enter the cloud through the internet, but there's multiple other options I can use that may be better for my users to use. And like I said, we do it all through the use of a single platform called GNX Plus, making it easy for you to transparently search, compare, quote, and order your internet services for all over the world that you may need. Everything is done through our single point of view here on the network. You can manage your services. There's 24/7 support and everything and more. This was my presentation. Thank you very much for listening. My name is Rick, and this was more than just a connectivity platform.
Thank you, Rick. Before we leave, maybe there's questions. You have the Q&A available. We have 5 minutes. I cannot see any questions.
I do have a good question here. The first question is, do you also offer low orbit satellite solutions? Yes, we do. The incumbent, of course, Starlink is what we work with a lot, but we also have other solutions available. Low Earth orbit satellites, for people who are unaware, is indeed a new way of connectivity, how I can connect in quite a low latency way, independent of network infrastructure that is physically present in the ground. So it's done through satellites that hover across the earth. And of course, SpaceX with their Starlink offering is the dominant player in the world that are actually delivering a very good service. And we definitely position that in many different cases with enterprises that need diverse connectivity in hard to reach locations. So getting a single fiber in is possible, but getting a fully redundant solution there is quite impossible. So we use the Starlink offering there, or we use alternatives when they're available. And then the next question: what is a benchmark for good latency? That's a very good question with a tough answer, because it really depends where you are in the world. What is good latency or not? Like I said, so we are here in our office in Utrecht in the Netherlands. A lot of data is hosted in the Amsterdam region. So from here to Amsterdam, it's only 30 kilometers. So the latency can be good, right? The latency can be 4, 5, 6 milliseconds going to the server. So extremely low. If I'm somewhere more rural, like in the middle of France, on a farm or in a small town there, and I need to connect to resources in Paris or in Germany or in Amsterdam, the latency will be already a lot higher. So that will be in like that 30, 40, 50 millisecond range. And again, if you already are far away from the resource that you need to connect with, having a bad connection then is going to very much impact how good your performance is. So what is a good benchmark for good latency? It really depends on the distance, right? That's the biggest aspect of latency, combined with the performance of the ISP. A good example for that is I was comparing ISPs here in the Netherlands with each other, depending on access technology. So if you have a fiber connection into your building, or if you're using a DSL, a cable, or indeed Starlink, just those different access technologies, even utilizing pretty much the same path to the certain server, heavily impacts latency. And of course, because the distance is so low, it differs between like 6 milliseconds on fiber, and then 10, 11, 12 on DSL, and then slightly higher on coax. But like you see, if I'm talking about this, it's already double the latency, right? I mean, and the difference between 6 and 12 is not really, you can't really feel that as a user. But if you're, again, in that rural piece of France or in Germany in a bit more remote location, then you will have either, like, let's say, like I said, 30 milliseconds, or you will have 40, 50, 60 milliseconds of latency. And that is what you start to feel. So benchmark is good, depending on where you are.
More questions?
Now we have no more questions. I see. Question is, shouldn't it be measured in round trip time? So yeah, difference between latency, which is typically seen as one-way latency, so really the distance between the server and the client, or the client and the server. Round trip time is indeed that back and forth traffic, so pretty much double the latency. Not saying you can just 2x the one-way latency, because especially on the internet, you don't really know which route the traffic will take going to the server and coming back from the server to you as a client. That can be asymmetric, right? You can use completely different network paths, different transit providers, different ISPs, depending on how they're connected. So indeed, round trip time is definitely a better measurement than one-way latency. Then another question: what is the greatest challenge you see in the market with companies that have global presence moving away from MPLS towards more DIA or broadband solutions? What would you advise them? It really depends on the use case. We typically see all customers moving to a full DIA/broadband offering and moving completely away from MPLS. We have 0 customers asking for that. It's also, I mean, we're not selling MPLS, but it's also not what we see in the market. We don't really see any RFPs for that anymore, unless it's a very specific region. For example, in the Middle East, there are some use cases where MPLS is pretty much the only option. Because it's been historically there, and there's not that much coverage within the region in the more remote areas. So then MPLS still has its place. Typically in other places all over the world, we see full internet stacks, where the difference between indeed a DIA, which is a dedicated internet access link, versus a broadband solution, which is more of a consumer product, is completely different. So DIA is highly available. It will have an SLA. It will have an engineer coming to your office if things will break down. And with a broadband solution, all those things don't really happen. Even if vendors will give you an SLA on it, it may not be the best. And if they do break it, then the penalties are not that high. So I always consider have at least one proper quality DIA in an office, and never run on 2 broadbands, because that will have a bad experience for your users.
I think those are the questions. And thank you very much all for attending. Thank you for your questions. We hope to do this again very soon. We'll let you know for sure. And that's it.
All right. Thank you very much for joining. Have a good day.